Good morning. Today we're going to be talking about factoring. Before we talk about factoring, let's take you back to previous chapter, chapter 5, which is multiplying. So when you're multiplying two polynomials, like 2x minus 3, let me take that, and I want to multiply that by x plus 5. Now to multiply that, if you remember, we used a method called what? The FOIL method, which says take these two, multiply them out. That's the first, the outer, the inner, and the last. So the result of that will be 2x times x, 2x squared. 2x times plus 5 is plus 10x. Negative 3 times x, negative 3x. And negative 3 times 5, which is negative 15. So when you clean that, we can say 2x minus 3 times x plus 5 is actually equal to the polynomial 2x squared plus 7x minus 15. Again, this is multiplication. This is not today's topic. Just reviewing old stuff. Now, this is called a factor. This is also called a factor. And the result is called the product, or polynomial. Now, factoring is actually the reverse of multiplying. We're going to give you this and ask you to change it to this. That's what factoring is. So factoring is we're going to give you the polynomial 2x squared plus 7x minus 15 and ask you to rewrite that as the product of 2x minus 3 times x plus 5. So that's where we're going with this lecture. Again, this is known as a polynomial. This is a factor. This is also another factor. How do we turn this to make it look like this? So we're going to be looking at some of the rules here to see how we can change this expression or this polynomial and make it look like that. But before we get to that, let's talk about something called common factor. That's the first thing I started with, common factoring. What's a common factor? Common factor. Let's just talk about numbers even. The common factor of two or more integers is an integer that is a factor of each integer. Yep.
You're welcome. You're welcome.
Okay. Okay. So let's take an example. Let's say we have 24 and 36. And we are looking for common factors. Well, 24, I can write that as 2 times 12. And 36, I can write that as 2 times 18. So 2 is a common factor. Notice it is in both numbers. Also 24, I can write that as 4 times 6 and 4 times 9. That means here 4 is a common factor. I can write that as 6 times 4. 36 is 6 times 6. 6 is a common factor. 24 also can be written as 12 times 2. And this is 12 times 3. 12 is a common factor. So notice there's a lot of answers, but when you look at the 12 is the largest common factor. We can't find a bigger number that's common to both of these than the 12. And that will take us to the topic, the greatest common factor. So my 12 here is the greatest common factor. So the greatest common factor of 2 or more numbers is the largest. The largest integer that is a factor of each integer. So the greatest common factor, largest. So we call that GCF. So when they define the GCF, that's the greatest common factor. The biggest number that's common, or that is a factor of each of the integers that we have there. So how do we find these numbers? How do we find the greatest common factors for integers only? Let me give you 3 numbers and see if we can find the greatest common factor. What is the GCF, the greatest common factor, of 24, 72, and 96? And it's not as easy as the previous example. Probably the easiest thing is to go back to pre-algebra and rewrite each problem using prime factorizations. If you recall, the prime factorization, we just take the 24 and says, give me two numbers. If you multiply them, the answer is 24. Oh, 4 times 6, good, that's 24. But neither one of these numbers is a prime number. So break it down more. The 4 is what? 2 times 2, these are prime numbers. Let me circle them. The 6 is what? 2 times 3, these are prime numbers. So the 24 is 2 times 2 times 2 times 3. Let's take the 72. 36 times 2. 2 is a prime number, 36 is not. 36 is 6 times 6. None of them is a prime number. The 6 is what? 2 times 3. So when you write the 36 now, there's a 2 here. Let's list the factors, the prime factors of it. Times 2, times 2, times 3, times 3. I got 1, 2, 3 2s, and 2 3s. Let's take the 96. I know 96 is 4 times 24. You can try 2 times 48. You can try any combination, but 4 times 24 is 96. Neither one is a prime number. Break it down to what? 2 times 2. 24 is 4 times 6. Neither one is a prime number. 2 times 2. The 6 is what? 2 times 3. So the 96 is 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s, and 1 3. And now once we factor these completely, let's find the GCF. We need to find the largest number that is a factor of all three numbers. Well, quickly I see they all have a 2 in them. There's this 2 common to all of them. So it's 2 times. Oh, I see another 2. That's common to all three numbers. Times. I see another 2. Any more 2s? No. This has it, this doesn't. I also see a 3 common to all of them. And that is my greatest common factor. Now if you multiply these numbers out, what's 2 times 2? 4. 4 times 2, 8. 8 times 3, 24 is the largest integer that is a factor of 24, 72, and 96. And if we thought about it, we can say, well, 24 equals 24 times 1. 72 equals 24 times 3. And 96 equals 24 times 4. So we can see that 24 is the largest common factor. We're going to do the same thing if you have variables like x's and y's in them. We're going to repeat the process. So let's take another example. Find the greatest common factor of 35 x y squared and negative 21 x squared. So let's take the 35 x y squared. That's all multiplications. We just don't put the dots between them. 35 is what? 5 times 7 times x times 2y's. The negative 21x squared, it's negative 3 times 7. Notice I could have used 3 times a negative 7, but I'm trying to match this one. So that's why I chose the negative 3. Or if you don't like that, you know what? Make it negative 1 times 3 times 7. That's even a better choice. Negative 1 times 3 times 7 times x times x. And when you look, you'll see common factor is 7. I also see an x. So the greatest common factor is 7x. Another example. What is the greatest common factor of a to the third a squared and a? Here we go. A to the third. I can write that as a times a times a. 3 of them. A squared. I can write that as a times a. 2 of them. A, there's only 1 of them. So the greatest common factor, only 1a. Find the greatest common factor of negative 18 x to the third y to the fourth and 12 x y squared. Let's take the first one, negative 18 x to the third y to the fourth. There's a negative 1 times what? We can take the 18 and make that 3 times 6. X cubed is x times x times x. Y to the fourth is y times y times y times y. The 12 xy squared. 12, I can do 3 times 4, but I'm looking for common factors. I got a 6 here. So maybe 12 is 2 times 6 times x times y times y. So I want to make sure I match these numbers on the top. So now I see the greatest common factor. I see a 6 I see an x, I see this y with that y, and this y with that y. So the greatest common factor is going to be 6 times 1x times how many y's? 2. You don't have to put the dot between them. 6x 2y's, or y squared. Now, as the expression gets bigger, you really don't want to break it down to every single one. So when you look at them, for example, what is the greatest common factor of 3a to the third b and negative 15 a squared b to the fourth? Now what I will do, instead of doing it this way, break it down to every single individual factor, I might look at the numbers, the 3 and the 15. I said, what is the largest number? Don't worry about the minus. 3 and 15. What is the largest number that I can divide this and this by? And the answer to that is 3. I can divide the 3 by 3, and I can divide the 15 by 3. So my greatest common factor is going to be 3. That's for the numbers. Then I look at the a's. This one has a 3, this one has 2. They have to be common. So the largest I can take is 2. Let's look at the b's. This only has 1 b, this has 4. The largest one is only 1, because it has to be in both of them. This does not have more than 1. So that's my greatest common factor, 3a squared b. Now, I started the topic by talking about common factor. So we finished talking about common factor, except how do you factor that? We're going to talk about factoring. We didn't talk about factoring yet. We just found out the largest thing, the greatest common factor. But how do we factor it out? So factoring the greatest common factor, GCF, the greatest common factor, from a polynomial. And again, before I get to that subject, factoring out, let me take going back to the previous chapter. We used to give you a problem like this. I said, multiply these. 3x times 2x plus 7. Three x times 2x plus 7. And we ask you to multiply that. And if you recall, the way we multiplied that, we distribute that. We went this way and that way. So this became what? 3x times 2x plus 3x times 7. And my answer will be what? What's 3x times 2x? 6x squared plus 3 times 7 is what? 21x. Well, factoring out the greatest common factor is the reverse of that, is taking this expression and working it backward, rewriting that as 3x times 2x plus 3x times the 7 And notice since 3x is common to both of them, we take that outside and we go what's left in each one. What's left is the 2x plus what's left in this is the 7. And this is factoring out my greatest common factor. Notice it is a factor because you're multiplying, and that's the largest thing they have in common. So let's take an example here and go through it. So if I have 10y squared plus 8y to the 5th, and the question is factor. And when we say factor, we mean factor completely. Meaning what? Find the greatest common factor, not any factor, the greatest one. This is 8y to the 5th, in case you can't read it. That's a 5 on the top, really. It's hard to read there. It looks like times 5. So let's look at the numbers, the 10 and the 8. We can divide these numbers. The largest number we can divide them by is the 2. I can only divide the 10 by 2 and 5, the 8 by 2 and 4. So the greatest common factor, so I can take that as 2 times 5. And the other number, leave a space there. And the 8 is what? 2 times 4. Now, this has 2 y's, this has 5 of them. So what is the greatest common factor? What is the largest thing they have in common? Well, they have in common the 2. And then what about the y's? Well, remember that y to the 5th, really I can write that as y squared times y to the 3rd. Remember, when you multiply, you add your exponents. So now you can see they also have y squared as common. So it's 2y squared, and what's left? There's the 5. That's the only thing left on this side. On that side, what do we have? 4y to the 3rd. And that is my greatest common factor. Let me try another one. Factor. (21) a squared b minus 14a. Let's begin with the numbers. Both of these numbers, the 21 and the 14, are divisible by what? 7. So 7. And this is a squared, this is a. The largest I can take out is a. This has a b, this does not. So what is left in the first one? Let's look and see. 21 divided by 7 is what? 3. I have a 3 left here. There's 2 a's. I took 1 outside. That leaves me with 1 on the inside. I have the b. I didn't touch it. It's right here. There's the minus. 14 divided by 7 is what? 2. There's the 2. I took the a out. There's no a's left here. And that is the last thing. That's my answer. Again, if that was too fast for you, we could have wrote this at 7a times the 21, that would be 3, 1a, 1b, minus, this will be 7a times the 2. And notice the 7a is the common one to both of them. And what is left in this is only the black writing, the black ink. Let's take this one, 8 a squared b squared minus 6a b to the third. Let's begin with the numbers. 6 and 8, they're both divisible by 2. A squared and a, the largest thing is a. B squared and b to the third, 2 b's and 3, there's 2 of them. So I can write the first one as 2 times 1 is 8. 2 times what is 8? That's a 4. A times what will make it a squared? Another a. And I already took the 2 b's out. Minus, again, this step is really optional. Soon enough, you become good at it. You can bypass step number 2 and go to step number 3. 2 times what will make it 6? That's a 3. I took the a out. There's no more a's. I took 2 of the b's out. That means there's 1 b left. So my answer is going to be 2ab squared, that's common to both, times 4a minus 3b. Let's try another one. Factor. 24 a squared minus 48a plus the 12. Notice 24, 48, and 12, they all happen to be divisible by 12. The 24 is 12 times 2. The 48 is 12 times 4. And the 12 is 12 times 1. So that's 12 times 2 times a squared. That's 12 times 4 times a. And the 12 is 12 times 1. You have to put the 1 there. So when you look now, the greatest common factor, the only thing they share, they can't take any a's. This doesn't have any a's in it. The only thing they have in common is actually the 12. And if you take the 12 out, what's left in this is 2a squared minus 4a plus the 1. Don't forget the 1. A lot of people want to leave it blank or 0. No, because when you multiply this, if you put a 0, what's 12 times 0? 0. You will not have that term. So you have to have the 1. 12 times 1 is 12. And the last topic in this video is factor by grouping. Be patient. I know you're getting tired. It's too early. if I have this problem, y times x plus 2, that's the first term, plus 3 times x plus 2. You can see actually the x plus 2 is common term there, common factor. So I can write that y times, I like to put the common factors in red usually, x plus 2 plus 3 times x plus 2. You can see the x plus 2 happens to be in both them, and just like the previous one, just like the other examples we did, when we have a common factor, we took it outside the parentheses, and whatever left, we left inside the parentheses. So do the same thing here. Take the common factor out, which is what? X plus 2 outside. And what is left here? In the first term, the only thing left is the y. In the second one, the only thing left is the 3. So it's x plus 2 times y plus 3. Let's factor again. Three y x minus 1 plus 2 times 1 minus x. Uh-oh, we got a problem. This is x minus 1, this is 1 minus x. It's backward. Well, if something is backward, it's not really a problem. Why? Let me go to the side here and write this. This is what we have here. How is that? Is that equal to? I'm not sure. Is that equal? What about if I reverse that and put a minus 1 in the front? Would that give me the same answer? Well, let's see. What's minus 1 times x? Minus x. What's minus 1 times a minus 1? Plus 1. Since it really doesn't matter which one I write first, that's commutative property of addition, I can make that 1 minus x. That looks like the same thing as this. So I can use that logic here, and I can say, you know that 1 minus x? I'm going to make that, there we go, two times. In place of that, I'm going to replace that with negative 1 times x minus 1. That's what 1 minus x is equal to. And what is plus 2 times a minus 1? So I can actually write that 3y x minus 1 plus 2 times a minus 1, that becomes a negative 2 times x minus 1. So 2 times a minus 1 is negative 2. And notice this is common to both of them. Now I can take it outside. And what's left is 3y minus the 2. So a lot of times what we do when we see a problem like this, instead of going through all these steps, reverse this and switch that sign. If you reverse that and switch the sign, that's where you end up right here. You can bypass that step. So let me do it with bypassing the middle step here. Factor. B times a minus 7 minus 5 times 7 minus a. If you recall, these are backward. I'm going to flip this and switch the sign. Flip this and switch the sign. I'm going to flip this, make it a minus 7, but I have to switch the sign of that. That becomes what? Plus 5. I jump from this step to this step instead of going through this one. Now these two are the same. And what's left here? B plus the 5. The factor by grouping really applies when you have 4 terms, not this one here. Here is factor by grouping. xy minus 4x plus 3y minus 12. What I'm going to do, actually, look at the first 2 terms. Look at these 2 terms and look at these 2 terms separately. Look at the first 2 and let me factor that. And when you look at them, what do they have in common? They have an x as common. So this is what? If I take an x out, what's left? Y minus 4. And let's look at the second group here. What do they have in common? The greatest common factor for them is a 3. If I take the 3 out, what's left? Y minus 4. Notice now you have a y minus 4 in both of them, which I can factor it outside. When I take the y minus 4 out, what's left there? I have an x left, I got a 3 left. And that's factoring by grouping. Let me try another one. Six h minus 6k minus h squared plus hk. Now again, take the first 2 and look at them, factor them, and look at the second 2 and factor them. This have 6 common factor, there'll be h minus k. If I leave the minus sign outside, this will have an h as common, 1h. So there's 1h left here, but it has to be a minus k, y minus. What's a minus h times h? That's a negative h squared. What's a negative h times a negative k? Negative times a negative will make it a positive. So again, some of you might be wondering, why did it change from plus to minus? Because I factor out a minus here. Minus and a minus will make it a plus. Now notice these 2 are the same, h minus k. That's my common factor. And what is left? 6 minus h. One more. 5y minus 5z minus y squared plus yz. Again, the first group and the second group, look at them separately. The first group, factor of 5 out. What's left? Y minus z. Here's the minus sign. These two have a y as a common factor. What's left is y. Again, because I factor the minus sign, this will have to change to a minus z. Minus and a minus will make it a plus. Y minus z is common to both of them. What's left is 5 minus the y. And that's the end of this video. You should try all these problems as often as you can, as many times as you can, because I'm telling you, if you become good at factoring, the rest of the semester will be a lot easier.